Hello all of you, this is Professor Das. I welcome you all for Physics 111. The first page I am showing you is the textbook, Cotnell and Johnson, Physics 10th edition, publisher Wiley. We're going to the first chapter, which is about introduction and math concepts. That's the first page, where you have different units for different measurement, like length, then we have weight, then we have time. There are three different type of units: SI, CGS and BE. We'll be mostly using SI unit for physics class. CGS will not be using, maybe rare sometimes, or sometimes we'll have to change from one unit to the other unit. In that case, there's a conversion to be done. This page makes a copy of what you have in your textbook, defining all the three different units, and table 1 shows you the prefix that is used for, let's say, centi, milli, micro. All these are defined with 10 to the power. Okay, that you can see. That's in the second and third page. We have some math functions, which is basically trigonometry. See this right angle triangle there. We'll be defining the functions like sine theta. Theta is the angle, which I'll show you here. Theta is this angle here, and this angle is 90 degrees. H is the hypotenuse, this is your base, and the opposite side is your H0. So we are defining sine theta as you see here, H0 divided by H, which is hypotenuse. Cosine theta is HA divided by H. Tangent theta is H0 divided by HA. I also wrote down again here, H is the hypotenuse, H0 is the side which is opposite to the angle theta. Then you have height, which is adjacent to the angle theta here. Now we have inverse function also, which is mostly used in solving problems. When you go further and further, you will see that. See the angle theta, 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 all three of them defined with respect to different functions like sine, cosine and tangent. Theta is sine inverse, the function we already defined here. Cosine inverse, function already defined here, and tangent we already defined here. So as you see, and I told you, it's here also in figure 1.6, page 7. The inverse trigonometric functions plays an important role in solving problems. So you can go over the example number 5 on page 7. Then we can going to define the scalar and vector properties. Scalar are the properties for any thing we use. Let's say speed. Speed doesn't have a direction. Let's say weight of the body doesn't have any direction. So those are scalar quantities. Now vector should have direction. For example, velocity. So velocity has to have direction. So vectors are main topic here we're talking about. So you can look into figure number 1.9, 1.10, 111, and this is about addition of vectors, and it's on page 10. And vectors have a direction, as I said before, and there's an arrow mark on top of that vector sign. Now look at this. Again, this is a copy from your textbook, which already draw this picture, the triangle and the theta, this is 90 degree, sine, cosine and tangent, the functions here. And this is an example which is pretty much related how to use the trigonometric function to determine the height or base or hypotenuse, whatever those as per the problem. Okay, now look at this. We add in two vectors, as you see there. That's in figure 1.9. Both are in the direction of east, like 275 due east and 125, all in meters of course, due east. So when you add these two vectors, the resultant vector is r, which is 400 meters due east. There is another way to also do it, like as you see in the figure 110. We'll be using the Pythagorean theorem to figure out the resultant. So you have 275 meters square of it, 125 meters square of it. Then you take a root after we add these two squares, and the answer is 302. In figure 11, I mean 1.11, you will be using the tangent function, where theta is tangent inverse b over a. Then we have theta again, tan inverse 125 over 275. Okay, then you get this answer, which is 24.4 degrees. This is pretty much all the pictures I have. I copied down from the book. We have 9, 10 and 11 here, all of them, and how to do also by measurement. This is also shown here. Okay. The next topic is the subtraction of vectors. Let's say you multiply the vector by -1, then the magnitude of the vector remains the same, only the direction of the vector is reversed. You can go over yourself, example 7, page 11. In this page you see how you resolve a force. This is a force here. You want to resolve it to x line or x component, y component. There will be two components, and how we figure out the resultant by using Pythagorean theorem. That will be the last topic in chapter 1. So I'll have more details after one day. On Tuesday I'll post it. You can go over all these topics which I just covered today, so that you are ready. We can do some problems and some other problems, either it is from your book or from the problems I have, and how to figure out the solution using the component method of adding or subtracting vectors. Okay, that's all for today. I'll try to post it, the other details of the x component, y component, or the component method of finding the resultant in a day or two. But in the meantime, please spend some time and go over the details in your book, and also the examples worked out in the book. That also is important, so that you can understand better when we'll be winding up chapter 1 this week. Okay, thank you very much. I'll talk to you again within a day or two.